Okay, look, some examples on Pearson's correlation coefficient, also known as product moment correlation coefficient, but I'm going to call it Pearson. Right, it says this formula is on page 17 of the formula book. That's a lie. On your formula book, it will be on page 5. Okay, the specification says you should always use your calculator to calculate it. However, this is in the formula book, so maybe it's there because they think one day you'll use it. So we'll look at that as well. Okay, so this example says, here's some data, and here are these things that we need for the formula. Now, if you had this, you'd put the data in your calculator, you'd ignore the other values. Okay, really the formula is only there if you're just given these values. Okay, so let's put the data into our calculator. Well, the first thing doing statistics on our calculator is to go into the correct mode. So we need to do menu. We want to be in statistics mode 6. But now, instead of one variable mode, which is the usual one we're in, okay, we're going to go for the second one down. A plus bx is the equation of the straight line. And remember, for correlation and regression in the A level, we're just interested in fitting points to maybe a straight line if there's any correlation there at all. So we're going to choose option 2. Now that means that if you come back to your calculator, you've got to remember to go back into option 1 if you're just working out plain means and standard deviations. So I'm pressing 2 for this one here, and I now have, I've already turned frequency on my calculator. It's going to be very rare that the frequencies are going to be anything other than 1. So I'm just going to enter the x and y values from my table. I've got x's and y's. Okay, so my first x value is 1. In fact, my x values are just 1 to 8. And it's actually quite convenient to do 1, 2, 3, 4, 5, 6, 7, 8 and enter all the x's and then put the y's in afterwards. Okay, but I do have to be very careful. This is all or nothing marks, so if I make just one mistake in entering values, I'm going to get the wrong answers out. So it's worth double checking everything. So one way of doing that is to do what I'm doing now and then clear it and re-enter the data and check I get the same answers. So I've got the first two values for y were 3 and 8, and I'm going to type the others in. So there we go, I've put in all 8 rows. Now to get some useful numbers out, some calculations, I need to press the option button. Okay, and then I'm going to be doing 2 variable calculations. That's why I did it. And I'm also going to do regression calculations. In fact, I think it's regression calculations that shows me the value of r. So press 4. Okay, as ever, the font is quite small. Sometimes there are minus signs that you can't see here. Remember, R can be negative. But on this particular case, I can see that R equals 0.7567. So that's all I need to record as my answer. Now, there may be, 2, maybe even more marks for calculating that. So it's absolutely vital that you make sure that you have entered the data accurately. So do it twice if you've got time. Now, as I say, you're unlikely to have to use this formula. Well, I don't know. It's there in the formula book. So if you do need to use it, it's very simple. You just put the values in. So R equals, okay, SXY. We've got an SXY which is 39.5 divided by the square root of SXX times SYY. So this is 42 times 64.875, but the square root extends over all of that, and to enter that in your calculator you need to be in menu 1. Okay, if I can do that. You need to press AC to get off that screen, then menu and then 1. And if you use this fraction button on your calculator, then you can actually enter calculations like the one we've got here. So I'll move the calculator this side, try and get it so you can see it. So I need 39.5 on the top, and on the bottom I need a square root, and it gives me a square root that will expand to cover everything I put inside it. So 42 times 64.875, press equals, and I get something completely wrong. So what have I done wrong? I've put a 34 here when it should have been a 64. So as ever, check everything. In this case, I've got 2 ways of getting the answer. But of course, an answer of 1 point something is bound to be wrong. A correlation coefficient cannot be more than 1. So I'd have known that was wrong. So I've got the same answer of 0.7567. Okay, some of these later figures may not be precisely the same because this looks like it may have been rounded and that does as well. So maybe they're not exactly the same. We don't care, we've got the right answer. Okay, all right, so let's do a more interesting example where this is actually in a context. So example 2, okay, we have got to apply this to this particular data about rainfall. So what have we got to do? So any question with more than about 2 words in it, you need to be underlining the instructions. So we're going to be working out Pearson's correlation coefficient. Well, that's okay. I can lob this into my calculator. Okay, it says use my calculator, and then it asks me to interpret it. Okay, so there's a bit that's just a repeat of what we did above that you could pause this video and do by yourself before you get on to the next bit. Go on, do it. Go on. Okay, well, hope you've taken the trouble to do that. I have, and hopefully I've done it carefully enough. When I press Option and Regression Calculations is number 4, and I'm getting an R value of 0.9428, that is. R equals 0.9428. Okay, all right, so that was the easy bit, getting the value of R. And now, what does this value show about the relationship? Okay. All right. Well, we've got to comment in context. So, in context means that I don't talk about X and Y. I don't just talk about whether there's correlation or not. I have to refer to rainfall and yield of wheat. But I also have to do 2 other things. I have to talk about how strong the correlation is, okay, and whether the correlation is positive or negative. Now remember these guidelines about strength of correlation. Actually, these are not in your notes, but if you haven't already done it, okay, put these guidelines, okay, you just need to write down the word. So strong, well actually, no, well let's go for almost exact for that one. Let's go for strong positive correlation for that one. Let's go for some positive correlation for 3 to 7. Let's go for almost no correlation for 0.1 to 0.3 and no correlation for anything less than 0.1. So make a note of those. You can put those in your notes, okay, all right, on this particular page here, all right. You've probably fit them in here. Just make sure you've got a record of those guidelines. So for the one we're doing, we had 0.94, so this is almost exact positive correlation, almost perfect positive correlation. So this is almost perfect. Is it positive? Yes, it is, because it's not a negative number. I checked that. So it's almost perfect positive correlation. Have I done enough? No, I haven't, because this is not in context. I have to say what the correlation is between, and I have to use the names of the variables. And that's an incredibly easy thing to do, because the variables have to be defined in the question. Okay. Now I could go further. In fact, you need to be aware, as has been said in a previous video, that correlation does not prove causation. So although it may be the case that the yield of wheat is higher when the rainfall is more, when there's more rainfall, it could be that the rainfall has caused the higher yield of wheat, but that may not be true. So we can say that there is no guarantee that the rainfall changes have caused the change yields of wheat. Now, in the days of AQA, this sentence here would have been all we'd need, but we're moving over to EdXL, so that's the syllabus you're doing, and it may well be that they want you to actually explain what correlation means. So how can we get this idea across without using the word correlation? Well, all we have to say is that when there was a lot of rainfall, there tended to be a high yield of wheat, So we need to be contextual here. First variable tends to be associated with the second variable, and because it's positive correlation, when this one's high, this one's high. If it was negative correlation, then I could say high rainfall tends to be associated with low yields of wheat. Okay, so because we're starting a new syllabus, I want you to do both things. Almost perfect positive correlation between rainfall and yield of wheat. So strength of correlation, direction of correlation, name the variables, and explaining without the word correlation that high values of one tend to be associated with high values of the other, naming the 2 variables. Hope that helps.